Assalamu alaikum. In last lecture we ended at chapter number 4. Now we have to start chapter number 5, transition element. I will try to cover all the second year material as well as your CAT college aptitude test preparation as well. So you have to keep in touch with us. Chapter number 5, transition elements. What is the meaning of transition? Transition means change of properties, and the transition elements can be defined as those elements whose electronic configuration ends on d or f orbit are called transition elements. In definition, you have two main orbits which are d or f. It means you have two main blocks in transition elements. One of them is D block and the second one F block. In D block, the valence configuration should be ns2 or n-1d. While for the F block you will have ns n-1d n-2f, and the number of elements you have to remember that in D block you have 4 series. In these 4 series you will observe that each series have 10 elements, while F block have 2 series and each series have about 14 elements. The elements of transition can be categorized into main types. Transition elements can be categorized into main types. One of them is known as typical elements and the second one non-typical. For the sake of typical element, you have to remember that elements whose d orbit is partially filled. And for non-typical, you have to remember that d orbit is completely filled, or you can say that d orbit is completely empty. Usually typical element give color compounds and non-typical gives no color compounds. Further, you have to remember that there are 62 elements which are typical and 6 elements which are non-typical. In these 6 elements, there are 2 main groups. One of them is 2b and second one 3b. 2b includes zinc, cadmium and mercury, while 3b scandium, yttrium and lanthanum. The oxidation state for 2b is +2 and the oxidation state for 3b is +3. 3b is +3. Further, we can categorize transition elements also in group. If we are going to discuss group wise, you will have 8 groups: 3b, 4b, 5b, 6b, 7b, 8b, then you have 1b, and at last you have 2b. As per new periodic table, 3b is referred as group 3, 4b as 4, 5b as 5, 6b as 6, 7b as 7, 8b as 8, 8b also referred as 9, 8b also referred as 10, while the 1b is referred as 11, 12b, 2b as 12. The valence configuration for D block group 3b should be NS2 N-1 D1. You can also have group number from your valence configuration. The number of electron in S is 2 and in D is 1. 2 plus 1. You are going to have your group number 3 or 3b. Similarly for 4b, NS2 N-1 D2 and 5b, NS2 N-1 D3, 6b. You have to remember that 6b violate of Gauss principle as NS1 N-1 D5. In actual, as per Gauss principle, it should be NS2 N-1 D4. But in actual, this S, the outermost orbit, loses or give that electron to D orbit, which is the inner shell. That's why it becomes half filled. You have to memorize that there are 2 conditions of stability. What are these? It should be 100% fulfilled, or it should be half filled. There are 2 conditions of stability. For the sake of D orbit, you have maximum 10 electrons. Fulfilled would be 10 and the half filled would be 5. Group 7b, the valence configuration usually is NS2 N-1 D5. Group 8b, NS2 N-1 D6. 8b as 9, NS2 N-1 D7. Group 10 as 8b, NS2 N-1 D8. Group 1b, you have to memorize. This will also violate of Gauss principle and becomes NS1 N-1 D10. In actual, it should be like this. NS2 N minus 1 D9. But this S donates this electron to d orbit to make it fulfill. For 2b, you will have valence configuration NS2 N minus 1 D10. So you can memorize that the group number will tell you your valence configuration. As for 3b, S have 2 electron, D have 1 electron, 2 plus 1, 3. For 4b, S2, D2, 2 plus 2, you are going to have 4. 5, S2, D3, 2 plus 3, you are going to have 5. S1, D5, 5 plus 1, 6. S2, D5, 5 plus 2, 7. S2, D6, 8b, also known as group 8. S2, D7, 2 plus 7, you are going to have 9, which is also 8b. S2, D8, 2 plus 8, 10, you are going to have group 8b. S1, D10, 10 plus 1, 11, or when you have D is completely filled, you can have your group number with the help of S, 1 electron, it means 1b. NS2, N minus 1, D10, S2 and D10, 10 plus 2, 12. As they have completely filled electron, you can have your group number from S have 2 electron, that's why it is 2b. For the sake of F block. D block has been discussed. Now we are going to discuss F block. F block, you have to memorize that the valence configuration is N S N minus 1 D N minus 2 F. Right? How many series are there in F block? You have 2 series, which are these. One of them is lanthanide, and the second one actinide. Lanthanide belongs to period 6. Actinide belongs to period 7. As it belongs to period number 6, N would be 6. Then you have configuration 6 as 6 minus 1, 5D, 6 minus 2, 4F. For actinide, group period number is 7. Therefore, N would be 7. 7S. 7 minus 1, 6D. 7 minus 2, 5F. Okay. How can we fill this orbit? You have to memorize S will have 2 electrons in each series. And D always, when it belongs to F block, it will have 1 electron only. And the number of electrons for F would be 1 to 40. Copy this, then we will discuss our series wise. Have you copied? If not, then pause your video and copy please, because these are basic points which you have to memorize anyhow. Now we have to discuss element series wise. First of all, we are going to discuss D block series. D block, you have 3 series. One, two, three, 4, 5, 6, 7. You need 3 more. 7, 8, this one 9, and the last one 10. Right? There are 10 elements in each series, and we have total 4 series. But due to 4th series, which is a radioactive series, we neglect that series. First of all, we are going to discuss the first series. For the first series, S, T, V, C, अच्छा ये ABC मैंने कैसे लिखी ये अभी मैं आपको बताऊंगा. पहले एलिमेंट्स को मेंशन करें. स्कैंडियम, टाइटेनियम, वेनेडियम, क्रोमियम, मैग्नीज, आयरन, कोबाल्ट, निकल, कॉपर, and the last one is zinc. Repeat with me. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and the last one zinc. How can you memorize the atomic number? In first period you have total 8 elements. In second period you have 8 elements. 8 plus 8, 16, 16, and the 2 elements were present in your first period, which is the shortest. First, second, third. 2 plus 8, 10, 8 plus 2, 10 plus 8, 18, 18 plus 2, you are going to have 20. This was your first period, this is your second period, this is your third period, and this is your fourth period. S block element 2 elements, which would equals to 20. Now the next number would be for scandium 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Abbreviation like cricket. That's why you can memorize this as Sohail, Tanveer, Vihari, a district of my senior, Vihari, कब में फिर कोई नया कप जबरदस्ती जीतेगा, जीतेगा. याद हो गया. सोहेल तनवीर बिहारी कप में फिर कोई नया कप जबरदस्ती जीतेगा. स्कैंडियम, टाइटेनियम, वेनेडियम, क्रोमियम, मैग्नीज, आयरन, कोबाल्ट, निकल, कॉपर, जिंक. Okay. Now you have to remember that group 1B and 6B have problems in their configuration. Now you can write your electronic configuration as this belongs to period number 4, then it would be 4s 3d, 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 and last two 4s 3d and 4s 3d. This was your group number 3b because the series starts from 3b. Then you have electron as 4s2, 3d1, 4s2, 3d2, 4s2, 3d3. This is a problem creating group. Change the marker. 4s1, 3d5. Then you have same configuration. 4s2, 3d5, 4s2, 3d6, 4s2, 3d7, 4s2, 3d8, 4s2. No. Problem creating group. Change the marker. 4s, 1, 3d, 10. Next, 4s2, 3d10. After the first series, I hope you can memorize this easily, electronic configuration as well as atomic number. Now we have to memorize the second series. Second series, Asian are well-wisher of their friends. Right? How can we make this trick? Yari, it means yttrium, zara, zirconium, nibhana, niobium, moth, molybdenum, tak, technetium, रुकावटें, रुथेनियम राह में, रेडियम राह में पड़ी, प्लेडियम अगर, सिल्वर कोई, कैडमियम यारी जरा निभाना मौत तक, रुकावटें राह में पड़ी अगर कोई, यट्रियम, जिरकोनियम, नियोबियम, मोब्लिडीनियम, टेक्नीशियम, रुथेनियम, रेडियम, प्लेडियम, सिल्वर, कैडमियम. Clear? Now we have to calculate the atomic number. For atomic number, the last one for the fourth period is 30. D block element, then 6 element of P block 36 and 2 of S block 38, and the next one would be 39, 40, 41, 42, 43, 44, 45, 46, 47, and the last one 48. Problem creating here silver, palladium, and molybdenum. Electronic configuration, that was fifth period, 5s, 4d, 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 5s. Oh, this was a special one. 5s, 4d. This is also special case. 5s, 4d, and the last one normal case, 5s, 4d. This is for group 3d. Then you have electron S2d1, S2d2, S2d3, and this one S1d5. This one S2d5. S2, D6, S2, D7, and this one also a special case. So S0 and the D is 10. S0, D is 10, and the next one S1, D10, S2T10. And the last series, the third series. For third series, yeah, this is the trick. Liaquat have fun. Liaquat have fun traveling world wide, reach out Ireland, please ask him. You have to remember this by this trick. Liaquat have fun traveling worldwide, reach out Ireland, please ask him. Lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, and the last one, mercury. How we can have atomic number? For the atomic number, we ended at 48. 48 plus 6 of p block, you will have 54. 54 plus 2 of s block, you will have 56, and the next one would be 57. You have to memorize that in 6 period, you have 14 elements of f block. 57 plus 14, you will have 71, and the next one would be hafnium 72, tantalum 73, tungsten 74, rhenium 75, osmium 76, iridium 77, platinum 78, gold 79, and the mercury 80. Now we have to find electronic configuration. This belongs to period 6. 6s 5d, 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 6s 5d. And you have to memorize that after 72 you also have 4f. 4f, 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 4f. Success 2 5d1, 6s2, 5d2, 4f, 14. 6s2, 5d3, 4f, 14. 6s1, 5d5, 4f, 14. 6s2, 5d5, 4f, 14. 6s2, 5d6, 4f, 14. 6s2, 5d7, 4f, 14. 6s2, 5d8, 4f, 14, 6s2, 5d, 6s1, 5d10, 4f, 14, 6s2, 5d10, 4f, 14. Okay, problems in electronic configuration: chromium, copper, silver, palladium, molybdenum, tungsten, and the last one, gold. Right? You have to memorize all these at any cost. Now proceeding forward, you have group trends. Normally group friends of S block and P block you have studied in chapter number 3 and chapter number 4, which are similar in chapter number 5. New group friends present in chapter number 5 are oxidation state. Why we discuss oxidation state of chapter 5? Because they have variable oxidation states. Why they have variable oxidation state? For that sake, you have to memorize the picture. This is your atom's nucleus, right? This is your inner shell, one of the outer shell, then another shell, and one more shell. This is your outermost valence shell, as this black line will tell you S or P orbit, right? This is known as your valence shell, which have S or P orbits. Then this red line is for D, that is also known as penultimate orbit. Penultimate orbit, it means a orbit which is filled after the valence shell, and this green line is for F orbit, which is anti-penultimate shell. Anti-penultimate shell, it means inside a penultimate shell. For that sake, I am taking an example of chromium Cr, whose atomic number is 24 and the electronic configuration ends on 4s1 3d5. This 4s is your valence shell and this 3d is your penultimate orbit, which is inside your valence shell. It means electron will lose from 4s initially, and you have Cr plus 1. Your valence configuration becomes 3d5. Now 3d5 means you have outermost configuration 3s2, 3p6 and 3d5. 6 plus 2, 8, 8 plus 5, 13, and you have 18 electron in third shell. You have to make 18 electrons, then it would be stable. So chromium loses another electron, plus 2, 3d4. Then loses another electron, plus 3, 3d3. Then loses another electron, plus 4, 3d2. Then loses another electron, plus 5, 3d2 and 1. And in last, chromium will become plus 5 and 3s2, 3p6. Now it is stable. So you have to memorize that initially electron loses from the outermost shell, then a penultimate orbit. Due to this penultimate orbit, chromium have variable oxidation state. The most number of oxidation state are in chromium, and chromium have round about 6 oxidation states. And you also have to memorize the highest oxidation state is present in manganese as Mn plus 7. This oxidation state depends upon number of unpaired electrons. Number of unpaired electron. Greater the number of unpaired electron, higher would be the oxidation state. Copy this, then we will proceed to next topic, color. Copy. Copied. Okay, you have to memorize all these things at anyhow, because these will play important role during your test preparation. After oxidation state, we have another important topic which is named as color. For color, I will recommend you to study chapter number 3, first year chemistry, atomic structure, spectrum topic. Color. When D block element combines with ligand gives color compound. For color sake, you have to memorize that, you have to remember that Vibgyor factor. What is Vibgyor? Violet, indigo, blue, green, yellow, orange, red, which depends upon energy, frequency, wave number and wavelength. Right? One of the subtopic for color is crystal field theory. In crystal field theory, you have to keep in your mind that d orbit is degenerated. Degenerated into two categories: dx square dash y square and dz square, and dxy dyz dzx. dx square dash y square or dz square are nominated as Eg, and dxy dyz dzx are nominated as T2G. Right? They are known as low energy and they are known as high energy degenerate orbits, and the energy difference is represented as del oct, because usually D block elements give octagonal structure. D block element gives octagonal structures, and del oct is proportional to frequency, and the frequency generated gives wavelength between 4000 to 7000 degree angstrom, which is a visible region. That's why D block element give color compound, and this color depends upon number of ligands, geometry, coordination number. Coordination number. And the next topic, that is magnetism. Magnetism means repulsion or attraction in magnetic field. Repulsion or attraction in magnetic field. You have to memorize Bohr magneton to calculate any kind of magnetism in any of the matter, whose formula is n plus 2, where n is number of unpaired electron. I will give you two examples, zinc and iron. For the sake of zinc, you have to memorize that the electronic configuration for zinc is 4s2 3d10. Iron is 4s2 3d6. Atomic number of zinc is 30, atomic number of iron is 26. Right? D is degenerated into 5 orbits. 5 orbit means 5 to the 10. To 5 the 10. Each degenerate orbit have 2 electrons capability. Then there are no unpaired electron in zinc, and would equals to 0. And for the sake of iron, 6 electron, it means 5 single, then a pair, 1 pair and 4 single. 4 single means n equals to 4. Now using Bohr magneton, Bm 0, 0 plus 2, 0 plus 2, 2, 2 0, 0. Therefore, zinc can't be attracted. Zinc can't be attracted or repulsed in any of the magnetic field. While iron, whose number of unpaired electron is 4, Bohr magneton becomes 4, 4 plus 2, 4 plus 2, 6, 6 into 4, 24, and root 24. Root 25 is 5. Therefore, it would be less than 5, and you have 4.8 or something. It means it can be attracted or repulsed in any of the magnetic field. Now you have to memorize there are 3 main types of magnetism in D block element: para, ferro, and the last one, di. Paramagnetism, ferromagnetism, diamagnetism. For paramagnetism, you have to memorize that it have unpaired electron. Ferromagnetism, it have unpaired as well as paired. Diamagnetism, all are paired. All are paired, it can't be attracted by any of the magnetic field. While these para and ferro can be attracted in magnetic field. We can understand diagrammatically as well. I have divided D into 5 degenerate orbits. As paramagnetism tell unpaired 1, 1, 1, 1. Paired and unpaired. Paired, paired, unpaired, unpaired, unpaired. Paired. I hope you got all of my points. You have to memorize all these, because for the sake of good grades, and good test score, you have to do all this in your mind, because all is your mind game. You have to show some interest in your studies. Thank you very much. We will continue in next lecture with IUPAC naming of inorganic compounds. Thank you very much.